So last class I discussed about summation of n numbers of n numbers. The n numbers were stored in the external memory, correct? Audible now? Am I audible? Yeah, fine. So two experiment we will do today. So experiment is basically okay, sum of n numbers. The second experiment is basically find element in an array. Okay, so this anyway last class we discussed this particular program in detail. That is sum of n numbers present in the external memory of external memory, which is interfaced to the 8051 microcontroller, correct? So the second one is same thing, okay, almost similar, but here we are trying to find the largest element in a given array. Okay, and your microcontroller. The particular microcontroller to your interface, that particular memory to the microcontroller. So this is the thing, and what we are trying to do. So assume that. So we need to find out the largest element in an array. Okay, let that element present in this particular location. Starting address of the memory is 8001. And there you have some number, say 32. Next number, second number is present in 8002, maybe 64, and like this, n numbers are there. So basically, in 800 memory location, I just kept the count value. Okay, I just kept the count value. So from next memory onwards, whatever you have, that will be considered as a data. Okay. Now, then after that, the objective is this. Objective is after the end of an array, you try to store the result back to the external memory. Okay, so whatever the largest element you found in an array, you try to push that particular thing to the external memory. So this is basically the objective. So now in this particular process, what we do, so we try to take the count value which is present in 800 memory location to microcontroller, and let us store that value to say maybe R0. Okay, save that particular count value in R0, first thing, and then what you do, one by one you take number from the external memory, okay, and compare with the largest. Say you store the largest element in say R1 register. So R1 register initially initialize that value to 00 and take one by one number from the external memory. Okay, so one by one element you take it from the external memory and then compare it. If the first element is greater than the stored value in R0, then you just know what you do, you interchange. Okay, you just reset that particular largest number to the number which is fetched from the external memory. Okay, so this is what you have to do. And then after a number of iterations, okay, then what you do, you store the result. Okay, you store the result back to this particular memory location. Okay, at the end of an array. So input output both will stay in the external memory. So this is basically the logic what we are trying to execute here. I'll just showcase the program. So if I use this particular logic, then the corresponding program is basically this. So you're able to see my screen. Step-by-step execution of this particular program. I just given it in the video what I shared, but here I'll explain. So now what is this? If you can see here, this is the part where you are taking the count value from the external memory. So 8000 register, I just kept the count value that I'm into or not. Okay. Then the second part is basically initialization of the largest element to 00. Okay. So whenever there is a larger value comes to the accumulator from the external memory, we have to exchange, correct? So that task I'll do. So I'll increment this particular pointer, that data pointer, I'll just write increment. Then it will point to the next memory location. Then I'll take the element from that particular memory. Okay. Then what I'll do here, this is the trick what we are doing. Okay. What trick we are using? We are doing something called subtraction operation. So what happens in subtraction operation? So you know that initially R1 is 00. Okay. So it does this particular operation. A is equal to A minus R1 when you execute this particular subtraction operation. As a consequence, what happens? The result is basically 32. Say if you store, in the external memory, first element is 32. So 32 minus 00, which is basically 32. Then in this particular case, result is 32. And also in this particular operation, there is no borrow. Okay. So borrow and carry both are having same meaning in the microcontroller. Okay, so borrow is not there or carry is not there. So borrow is not there. So that's why this element will become the carry bit or borrow bit will become 0. Okay. Now this is the some kind of if and else how you can implement if and else in microcontroller, basically by observing this particular carry bit. Okay. Now there is no carry. So now there are some instructions called jump on carry and jump on no carry. Okay, so this using this particular instruction, you can create if and else. Okay, you can create if and else. So now there is no carry. You have to do some work. If it is a carry, then what you have to do? In this particular case, if you have a carry, then you no need to what you have to do. If you have a carry, okay, if you have a carry, okay, then you have to you should not exchange. Okay, you should not exchange. And that means you should not reset the largest element. If you have a carry, if you don't have a carry, then you should execute the next instruction. So what is that next instruction? Accumulator content is basically the number which is taken from the external memory. So that should go and sit in the largest element place. That is R1. Okay. Now in this particular process, what happens? So here, if and else, I am trying to implement. If you get a carry, then you do certain instruction. If you don't get a carry or borrow, you do a certain instruction. So this is how you can implement if and else in microcontroller. Okay, jump and carry and jump and no carry. So that means if you get a carry, okay, then it will go to some different place. You don't get a carry, okay, so if you don't carry, then the next instruction will be executed. So that means you have created if and else.
Understand the logic.
Okay, you're not understanding this?
John, sir.
John, okay, John. So let me explain. External memory content is 32. Okay, so 32 I have taken. So initially what value you have in R1 is basically 00. Okay, now there are so now what you are trying to do, so you are taking this particular number to 32 to accumulator. Now you are performing subtraction operation, what subtraction between the A and R1. So in this particular process, what happens? Okay, so if the fetch number is greater, if the fetch number is greater,
Sir, you're breaking, sir.
there are two chances are there. That means what two chances? So the first number, maybe greater number, and maybe less number. Audible now?
So your voice is
Audible now?
breaking the whole time.
Audible? Am I audible? Okay, am I audible now? I just have some internet connectivity issue today.
Yes, sir. Now it's fine, sir.
Is it? It's fine now? Okay.
Yes.
So now, so I'll tell you the logic. The logic is this. So whatever the element you take from the external memory, either it will be, it will be no, greater than the stored element or less than the stored element. So that is the two
So
possibilities.
this
I'll tell you the
external
both the
memory is
possibility.
the array, sir.
Yes, external memory is the array. So this 32, no, maybe 12, 16, this kind of element may be present in the external memory.
So how is it going to the next element and checking?
Yeah, so now to the next element, say for example, if this is 8000th memory location, you are storing this particular address in DPTR. Okay, so when you increment,
So you're not audible, sir.
I mean, audible now?
Yes.
John? Am I audible now? John?
Yes, sir. Now you're audible.
Okay, okay. So I'm just outside now. I using my mobile internet, so that's why try to adjust. Okay. So you understood this part, John? How you can go to the next memory location by incrementing the DPTR content, you can move to any memory location in the external memory. So whatever data you store in DPTR, that is
So
data memory.
DPTR is the
So
address of this external memory.
yes, DPTR is basically called data pointer, the address of the external memory.
Okay, sir.
Store in this particular DPTR, your microcontroller always points to the particular address. Clear?
Yes, sir.
Yeah. So now coming to the logic. So now the logic is this. Now this 32 you have taken to data, and R1 is already you initialize that to 00. Now what happens here when you subtract 32 with by 00, answer is 32. So not only that, I told you any operation microcontroller, it will reflect in program status word. In program status word, there is one bit is called carry bit. That carry bit will become because there is no carry or borrow. Carry or borrow both are same microcontroller. You are clear about this particular part? The result and the carry bit, two reflections happens. Am I clear?
Yes, sir. Yes, sir.
Yeah. So now in this particular case happens now the second element. What operation? Same operations happens here. What is that? A is equal to 12 minus 32. Can you see the
Sir, you were
difference?
not audible till now, sir.
Up to what point you have to listen?
Sir, till that carry, you told that's it. Over.
Yeah, yeah. So carry bit is equal to 0. You understood why carry bit is equal to 0?
Sir, because 32 minus 0, there is no carry. So
Ah,
0.
0 carry, so carry bit is 0. So then what I'll do, I'll take the next element. I'll take the next element. So what is that next element? Next element is basically 12, right?
Yes.
So now what happens in this particular case? R1 is 32. 12 minus 32 is what is the answer? 12 minus 32
Minus 20.
minus.
Minus 20.
So now in this particular case, there will not be, the minus value has no significance. You should know here the memory, how the number rotates. Okay. So number, so now you see here, so 0 number and the largest element is FF. Okay. Now somewhere your 12 is here. So if you try to subtract 12, then what happens? 32 value, then what happens? It will subtract like this, and then from the down, it will take the remaining things. And whatever value you get here, okay, maybe something like, F0, something like that. This value will come. This is hexadecimal subtraction. You understood? So now what is minus 20? Okay, it looks minus 20, minus 20 in hexadecimal is what? 20 in hexadecimal is basically when you convert 20 to hexadecimal, what happens? What is the value? 32 is the value. So that many elements will decrease from this particular point, whatever value is there. So 32, so it may be E0. So, this may be E0. So E0 may be the result. The result of this particular operation is E0. So result is not relevant here. The relevant is carrier borrow bit. Carrier borrow bit. Okay, in this case, borrow will set to 1. You are clear about the point? The carrier borrow will become 1. In previous operation, since the second number is smallest, you are not getting the borrow or carry. In this particular case, second number is large, you are getting carry or borrow. Is it clear?
Yes, sir.
Yeah. So now what happens? So when the exchange, when carry.
Sir, is carry and borrow can be only 1 and 0 or something else? No.
Not reset 32 to 12. Only thing. So this particular logic will continue till the end of an array. Okay. So you understood carry bit is equal to 1. There will not be any resetting of the value. So 12 is the current value. We are not going to set that particular value to R1.
This carry can be only 1 or either 1 or 0 or nothing else.
Yes, nothing else. Carry cannot be, it can be 1. Whether you are taken borrow or not, that's the only question.
Okay.
Okay, so in this case, carry is equal to 1 or borrow, carry, borrow. 1 means don't exchange. You got it?
Yes, sir.
Yeah. So now when you repeat particular operation, okay, for n number of elements, okay, so what happens? Always, your R1, okay, your R1 holds the largest element always. Your R1 register holds the largest element. You got it?
Yes, sir.
R1 register holds the largest value. Fine?
Okay, okay.
Yeah. So in that way, I have written this particular program. Try to take a snapshot of this particular program and run this particular program and debug line by line and try to understand this particular program. Okay, especially in the place when jump carry is there, na, in that particular place, try to observe. Okay, so step by don't animate, step by step you just try to execute. And when you are feeding a data in the external memory, be careful that in 8000 memory location, okay, you have to keep a count value. Okay, so count value for 10 you have to store 0, yeah, and try to give some kind of mixed value like this. Okay, okay, so like this, you try to feed the value. Now you see, like this, you feed the value. Now it should be not global that some value. Say in my case, it's 77 is the highest value, largest value. So after 11, 77 should come. After 11, 77 should come. Okay, so when I run this particular program, so in the external take this snapshot of this particular program, please, and run this particular program. This one as well as the sum of n numbers. This one as well as sum of n numbers present in external memory. These two programs you have to execute. Okay. Please take a snapshot. Your screenshot you take. And we'll discuss, but you have to execute from your machine, then I'll come and I'll take a evaluation. And also you have to execute the sum of n numbers. Okay, this program also you have to execute. Okay, so this was explained in detail in the last class. So take a snapshot of this particular program as well. So you're clear about what you have to do in this lab?